So we're talking about obtuse angles. Last class we worked with angles in trigonometry that were acute only. They were between 0 and 90. An obtuse angle is the next stage over. It's between 0 and 180. Now there's more angles than that. There's reflex angles, but we're just doing a bit at a time. So today we need angles. We have to be able to measure. You're going to need a compass. If you haven't got one yet, press pause and please go and get one. We're going to start with a simple x and y axis like this. An angle is in standard position if the vertex is at the origin. So we're going to draw an angle and we're going to make sure its vertex is at the origin. The initial arm is on the positive x-axis. So the initial arm is on the positive x-axis means that I'm going to draw a line here on the x-axis. You guys should use a ruler, but my little pen tool skips a lot if I use a ruler. So I've labeled my axes x and y, and I've drawn on a red, it's called an initial arm. That's what I put on the x-axis. You should use a ruler for that, but my ruler doesn't work. The next part is to draw the terminal arm. The terminal arm rotates about the origin. So the terminal arm, so here's my initial arm right here. My terminal arm, I'm going to draw another line. So I could draw it right here. Right? Terminal means terminate. That would be the end of my angle. It would be between this red initial arm and wherever I terminate it here. If I did it here, then my angle's in between those. If I drew my terminal arm over here, then the angle would be from this red initial arm all the way to wherever I draw the terminal arm. All right, there's my terminal arm there. So you can put it wherever you want, but I want you to draw the same thing. Draw an initial arm here with your ruler, draw a terminal arm here. Now the measure of the angle is in between these two red lines, right? So I've created an angle with its vertex at the origin. That was the first one here. The vertex is at the origin, so my vertex is there. I've got an angle that we've created here, and I'm going to label that with theta. There's theta, and theta is always measured from the positive x-axis to the terminal arm. So theta is measured in this direction. So if we were actually measuring with our protractor, we'd be measuring in this direction. The direction becomes important later. The angle is one size, but we're always measuring up from this way. So that's your basic terminology here, the first parts of what we need to build on what we're going to continue with. And here's just a picture from your textbook showing the same thing, although drawn much better with the initial arm, the terminal arm, the vertex, and theta being right there, being the angle. Today we're only going to work with quadrant 1 and quadrant 2, and that's because the last lesson was quadrant 1. Quadrant 1 we were drawing triangles with just acute angles. Now today we're moving into quadrant 2. So although we will get to quadrant 3 and quadrant 4, and you might have some questions today saying, why don't you draw a triangle down there? We will do that, but today we're just doing one new quadrant at a time. So if the angle we're measuring is theta and it's in the first quadrant, then it's going to be acute. If we draw, so remember initial arm would be here, terminal arm somewhere here like the one we just drew, then we're going to have an acute angle. However, if we put our terminal arm in quadrant 2, our initial arm is always, always, always here. For the whole semester, the whole year, the initial arm will always be here. We always start here. So here's the initial arm of our angle. If I put my terminal arm way over here, then we're going to have an obtuse angle. All points in the first quadrant, so think back to grade 9 when you were graphing. If you put a point in the first quadrant, say right here, that would be 4, 5. That would be the coordinate 4, 5. All points in the first quadrant have positive x values and positive y values. No matter where you put a coordinate here, here's 1, 2, both the values in that coordinate are positive. But once we get into the second quadrant, if I put my laser pointer here, that's the coordinate -3, 2, right? So no matter where you put a coordinate in this quadrant, all of the x values are going to be negative, so put the word negative there, and all the y values will be positive, so write positive there. So all the points in quadrant 2 have negative x values and positive y values. In grade 10, you worked with circles. So here is a circle of radius 1. This circle that you're looking at becomes really important. This is called our unit circle. Unit meaning 1 unit. The radius is 1 unit. So we use this a lot, this circle. without your, so here's where it gets tricky. So you might have to press pause a lot and do your steps one at a time. So I'll go through them one at a time with you. We're going to, without a calculator, find sine of 72. So in grade 10, you just put this in your calculator, sine of 72, but you don't know what it means. What is sine of 72? It's just some number with a lot of decimals that your calculator gives you. In grade 10, you didn't really need to understand what sine of 72 was. So we're going to start going through the trigonometric ratios and figuring out exactly how does my calculator get an answer for that, sine of 72. So I'm going to show you now, you're going to learn how to get those numbers yourself. Find sine of 72 without a calculator. The first thing we need to do is draw an initial arm along the positive x-axis. So that's right here. You're going to draw a line there. Let me back that up. Okay, sorry, I went ahead to step 2 there. But your step 1, I want you to go ahead and draw an initial arm along the positive x-axis. So you're going to draw a line right here. It doesn't really matter how long you make it. You can make it all the way to the circle, you can make it beyond, or you can make it shorter than the circle. It doesn't really matter. So you're going to draw an initial arm here. Then use your protractor to measure 72 degrees. So you have to get out your protractor, and you're going to measure it from 0. So the 0 on the one that you're seeing here is the bottom number. So I'm going to go up this way, right? 20, 30, 40. I'm going to go to about 72, where I think the 72 is. And I'm going to put a dot on the circumference of the circle once I get to 72. So mine is about there. Remember to pause this when you need to. So you put your dot at the 72. So now I can get on to step 3. Okay, I've got my initial arm on there. I've got my dot from measuring 72 degrees. Now step 3 is to draw a terminal arm to the dot. Remember what the terminal arm is? So there's my terminal arm to the dot. Step 4, draw a vertical line down from the dot to the x-axis. So these, we've already done an initial arm and a terminal arm, so these two vocabulary we already have, but we have a new one now. We're going to create a triangle because that's what trigonometry is all about, triangle. So from this dot here, I'm going to draw a vertical line down to the x-axis. Never ever draw a horizontal line to the y-axis. We're always creating our triangles by drawing a line down to the x-axis. So there's my line down to the x-axis. Now that should be perpendicular. So I'm going to put a little box there because I should have drawn a perpendicular line if I drew that straight. The next, we're on step 5 now. Step 5 says, how long is the base of your triangle in units? So what I'm looking at right now is I'm going across from the vertex, which is at the origin here, right? And I want to know how long this distance is here. So you're just going to look at your picture that you've drawn and take an estimate. So if the whole, all the way out to the edge of the circle is 1, because it's remember it has a radius of 1. So each of these little grid lines is going to measure 0.1 or 1/10. So I'm looking across there, and it's a little bit more than 0.3, 0.1, 0.2, 0.3. Well, it's almost exactly 0.3. My blue line is pretty much coming down at 0.3. Now yours that you drew might be different. Whatever you have, so whatever you think this length is here, that's going to go in this spot right here. And then for what is the height of your triangle, so we go up to where I have my orange dot and I'm going across, and it's not 1, right? It can't be 1, because if it were 1, then it would be right at the top here. So it's a little bit shorter than 1. So mine looks like it might be about like 0.9, 0.98 even. It's really close to 1, or 0.97. So I filled in my values for step 5 and step 6, just estimating, right? You're just going to put an estimate down there. The next thing, step 7, is to write the coordinate at your dot. So I'm going up to the dot here. My x value, I'm writing it as a coordinate. My x value I got at 0.3, and my y value I kind of estimated that as a 0.96. So that's the coordinate of that point right there. The coordinate of the dot is at 0.3, 0.96. That's step 7. So step 8 is to label the hypotenuse length. So here's my hypotenuse here. Label the length of it. So remember that this is a circle with a radius of 1. That means from the center of the circle to any point on the circumference, any line, if I drew a line from the center of the circle anywhere, it's going to be 1. So the length of my hypotenuse is going to be just a 1. So we have our triangle all drawn here. Step 8 we finished. Sorry, we're underneath that. Sine. So let's go back to talking about what sine is. Back up to the original question. I said we were going to figure out what sine of 72 means without a calculator. So sine, we know, is opposite over hypotenuse. And in this case, so here's my angle right here. Let me just draw that in there. The angle that I created is the one we measured, remember, from the previous screen. This is our theta here. This is the angle that we created when we measure from the initial arm to the terminal arm. That measure is called theta. So when we put our theta in there, sine is opposite, sine of theta is opposite over hypotenuse, so sine. So here's my opposite right here, and here's my hypotenuse. So for what I've drawn here, the opposite is this side here, right? And this is also my y value. Remember when I was trying to figure out how high y is? So opposite over hypotenuse, I can now, instead of saying opposite over hypotenuse, I can also say y over r for the radius. So you already have SOHCAHTOA memorized. You know that sine is opposite over hypotenuse, but a new way to remember it now is y over r. And that's often helpful when we're on a coordinate plane. We're just looking for a y coordinate and then a radius, and a lot of times our radius is 1. So if we're going to fill in the unknowns, and we're going to check with our calculator. So let me go back to my pen here. So my y value, I'm just going to write it below here. My y value was 0.96 over my radius, which was a 1. So with your calculator, I want you to find sine of 72 on your calculator, okay, and see what you get. So when you put in sine of 72 on your calculator, you should be getting 0.951056, a whole bunch of numbers, right? That's this number here that we estimated. So I got a 0.96. I don't know if you got the same thing I did, or if your number's a little closer to 0.95. I was off by a bit, but that's how you find sine of 72. Without a calculator, sine of 72, you're drawing a 72-degree angle, you're finding your coordinates, and if you want sine, you only need the y value. Right? The y value is sine. We're going to get onto what the x value is later, but to find sine of 72, that's what your calculator is doing. That's where it's getting its number from. The last thing on this slide, if we always use a unit circle, like what we have in our picture here, if we always use a unit circle, a circle with a radius of 1, our hypotenuse will always be 1. In this case, we can state that sine of theta is always going to be the same as the y value, as long as your radius is 1. We're going to have other circles later where the radius isn't 1, and we're going to have a different number for our denominator, and that's okay. But if you have a unit circle, then sine is the same as your y value. So you draw a circle, you draw the initial arm, you draw the terminal arm. Whatever your y value is, that's going to be sine, as long as this is a 1 here. You won't have to worry about a different denominator. Next slide. Example 2. On this circle, draw cos of 152 degrees. This time, draw the angle terminal arm, then just label the coordinate dots. So get your tools out that you need. We're just going to draw the angle. So measure your angle first. Of course, you're always starting from the positive x-axis here. This is your initial arm. You're going to find 152, so we're measuring all along here, right? Looking at my lower numbers here, 0, 10, 20, because I'm measuring in this direction, 152. Put a dot on your circle when you get to 152, and draw a terminal arm there. So we've got our, just to put in the initial arm, there's my initial arm, there's my terminal arm, there's my coordinate, because I guessed at about where 152 degrees would be. When you draw a perpendicular line, so remember on the last slide, we were up here, right? We were up here somewhere, our terminal arm was up here, and we drew a line straight down. So this time we're going to draw a line straight down to the x-axis. When you draw a perpendicular line down to the x-axis from the coordinate, notice the triangle you've created does not have a 152 degree angle. So we're going to draw a line here. First, so I haven't labeled the coordinates. So we're going to label the coordinate at the dot with our best guess. So what do you think that coordinate is there? So take a look at your graph or take a look at my graph and see if you can come up with an x value and a y value. I'm going to put my x value here. Looks like it's maybe, it's definitely a negative x value, right? And it's always going to be 0 point because I'm on a unit circle. So 0 point, let's say, it's almost negative 0.9. So let's do 0.8, 87 or 88. I had to fix that. That was too sloppy. Now my y value is definitely positive because it's in the second quadrant here. So again, 0 point, and mine looks like it's almost exactly a 0.5 there, right? So I'm going to put 0.5. And remember, this is your angle here. This is theta, which we measured to be 152 degrees. So this is the principal angle. 152 is the principal angle. If you look over in the instructions here, 152 is the principal angle. But we're going to draw a vertical line down here to create a triangle, because we can't create a triangle on this side because our terminal arm is in the second quadrant. So we've got to draw a vertical line down here. We're going to put a vertical line down here, and that's going to be our related acute angle. So we're actually going to get an acute triangle on this side right here. Let me switch to my pen. So I drew a vertical line down to the x-axis right here. There's a triangle that's acute. So if this is 152, what does this little piece measure in here? What does this little angle measure in here? That's the related acute angle. So the angle at the vertex that I've created that is part of my triangle, what does it measure? So to figure out what it measures, we're just going to do 180 subtract 52, because 180 subtract 52, subtract 152 is going to give us this measurement in here. Because if we rotated all the way to the other side of the x-axis, we would have gone 180 degrees, but we didn't go fully 180 degrees. We're a bit less than that. We're 152 short of that. So the difference for that is 28 degrees. So 28 degrees is our related acute angle. But the original question asked for cos of 152. So cos of 152. Remember that cos is adjacent over hypotenuse. So I shouldn't have gone ahead there, but if cos is adjacent over hypotenuse, so here's my angle. This is my adjacent, right? This is the adjacent side of my triangle. This is my hypotenuse, which we know on this circle is a 1. So my adjacent, is that my x measure or my y measure? Which of these two is telling me this bottom length of my triangle? It's the x value. So my adjacent over my hypotenuse is going to be, in my case, I have 0.88, negative 0.88. That's my adjacent side. My hypotenuse side is a 1. So on your calculator, if you find cos of 152 and you find cos of 58, write them down here and see what the difference is. All right, hopefully you press pause and you did that. cos of 152 should be really, really close to the number that we just got. It is negative 0.88, so I made a good guess on that one. So negative 0.8 is cos, so cos of 152 is equal to negative 0.88. But cos of 28, when you put that in your calculator, cos of 28, you're getting the same answer, except this one is positive 0.88. The difference is, what's the difference? The difference is that cos of 152, this one is in quadrant 2, right? This one was obtuse. 28 degrees, your calculator, if you put 28 degrees in your calculator, it knows that 28 is acute. So it's assuming that you've drawn an angle in quadrant 1. Cos of 28 degrees, your calculator says, okay, quadrant 1, it's positive. Remember, all x values are positive in quadrant 1, whereas in quadrant 2, x values are negative. So your calculator, if you're telling it cos of 28, your calculator is saying, okay, that's got to be positive because x is positive in quadrant 1, whereas cos of 152 is in quadrant 2, and x values are negative there. Quadrant 1, x values, these are all positive. Quadrant 2, x values are all negative. So a key concept here is that any point on this circle, so going around this circle, again, we're just doing the top half today, but going around this circle, any point on this circle, on the circumference of the circle, with a radius 1 can be written as cos sine, because we've just determined that as long as we're on a unit circle, circle with a radius of 1, x is going to be the same as your cos, right? Here's what we got for our x value. That's cos. On the previous example, we found out that y was the same as sine. So we can say that cos is x and sine is y. Or when we're writing a coordinate xy like we did here, this would be cos of 152. This would be sine of 152. So if you do 152 sine in your calculator right now, just to check this guess, so our theta is 152, you do on your calculator sine of 152, okay, 0.469, so I was off there, but that's where your calculator is getting your cos and your sine from. What about tan? Tan, we know, is opposite over adjacent. So if we look at this circle and the terminal arm, here's our terminal arm for 152, what would tan be for this triangle? So tan, I'm just going to change to my pen here, tan is opposite over adjacent, okay? So the opposite of theta there, the opposite is 0.5. My pen tool is really annoying here. So I'm writing in opposite, hypotenuse, and adjacent on the triangle up here. This is our angle right here that we're talking about. And when I'm talking about tan, I need to know the opposite over the adjacent. So the opposite, remember I have measured that on my triangle anyway, 0.5. That's about what my opposite side measures. The adjacent side we have to be about negative 0.88. So if you put these two in your calculator, just do 0.5 divided by 0.88. Let me do that. 0.5 divided by 0.88 negative. I get about negative 0.568. Oops. That 2 didn't turn out very well. So that is tan. So on your calculator right now, I want you to, in your calculator, put tan of 152 into your calculator. So we're off by a little bit, right? That's because our numbers that we're using to come up with our coordinates are a little, they're estimated. So normally we would have a test, a quiz in this unit. It's a non-calculator quiz. And I could write down sine, cos, or tan of any angle, and you know how to figure it out because you would draw it. You definitely will have, you have a non-calculator test in advanced functions where you have to be able to do all this. So even though you can get all your answers on your calculator right now, you have to be able to understand where sine, cos, and tan come from without a calculator, just with estimating. So according to what we've learned, I'm looking at the very bottom of your screen here. According to what we've learned, cos is x, sine is y, and tan is y over x, which is sine over cos, because the opposite, right, here's my angle, my opposite is my y value, my adjacent is my x value. So I can write it as y over x, and that's also the same, because y is sine and x is cos, it's also the same as y over cos. So this is a pretty fundamental point here that you need to grasp. Next slide. Finding the angle with given sines or cosines. Just determine the angles for each equation and draw a diagram to represent it. So one at a time. You have on your handout that you've printed, it's pretty small, but I was trying to fit it all into save paper. Determine the angle for, so this time the question is different because in everything we've done so far, I gave you the angle, right? I gave you 72 degrees and you could draw it and you could figure out this number because you would draw it and then you would find in this case the x value because cos is x, right? So, but this is the opposite now. I'm giving you the answer and you need to go backwards and figure out the angle. I don't have the angle measurement here, so I'm giving you what the output is. Remember, a function, anything is a function if for every input it's got only one output. So that means 0.56 is my output. I got to go backwards and try to figure out the input. So here's my circle. So the first thing I have to do is put on, it's not very long there, but there is the initial arm. But this time the initial arm is only going up to 0.56 because x, we know cos is x, and this time we know the kind of the size of our triangle. We know x is 0.56. That's the original question here. So I go along my x-axis to 0.56. I went a little over there, but I go across my x-axis to 0.56 and I put my initial arm only that far. That's my x value. Then I go up to the circle. So on all the other questions, I had my dot already. I already had my dot, right? But now I'm going backwards. So I put my x value on, then I go up to the circle. There's my dot. Now I can measure it. So I'm going to measure the angle that goes up to the dot. Draw a line through the dot and measure it. And it looks like, if you look at my protractor there, we come up with our triangle here. So you're going to come up with a measure for this angle right here. So take a look at what you think that angle measures using your protractor. Press pause and get all that stuff down and find the measure of that angle there. So again, we're looking for this angle here. What do you think that measures? I don't know why that's disappearing. And when I check, I'm getting about 55 degrees. So it looks to me like my theta is about 55 degrees. We're all maybe going to have different answers, right, for what we think that is. But as long as we're drawing the triangle properly, we've gone over to a value of 0.56 here, then it's whatever your best guess is, 0.55. So that's how you find the answer. That's how you determine the angle if you're given the answer. It's a little bit easier, I think. The other one had a lot more steps. But if you're given the answer, 0.56, and you know that cos is x, and as long as we're on a circle with a radius of 1, I don't need to worry about the denominator. I don't need to do the adjacent over hypotenuse, because I know my hypotenuse is 1. Just need to look at the x. The x value is 0.6, so go across, put a dot, and measure it there. So I get about 55 degrees for that. And we can check that on our calculators. On your calculator, if you do, this would be inverse cos, right? So inverse cos of 0.56. And put it into your calculator, and I get 56 degrees on my calculator when I put this in. So again, if you're using your calculator, that's an inverse cos, because we're trying to isolate theta here. So we're looking for inverse cos of 0.56, so that's the cos to the -1, and then your calculator gives you the exact answer, but we're figuring out the answer without a calculator. That's the whole point of this lesson, is understanding the trigonometry, where it comes from. Another example, sine of theta equals 0.8. So remember that sine is y. Okay? Sine is equal to y. That means this is since I'm on a unit circle, I've got a radius of 1. That means that my sine value, 0.8, that's my y value. So I'm going to go up my y-axis this time. I'm going to go up my y-axis to 0.8. That's where I'm starting here, about there, right? That's 0.8. So sine is y, so all I know, the only clue I have is my y value is a 0.8. That's all I have to go on. So from there, I go over to my circumference of my circle and put a dot, but the dot's not coming on. Oh, there it is. Sorry, I did 2 steps at once. So I put the dot on and then my terminal arm. So that's my terminal arm there. My initial arm would be here, and measuring in here with your protractor. So it's important that you don't measure the wrong side. You're always measuring from the initial arm, right? Here's my initial arm. I'm measuring this right here. That will be theta. So that's going to be my theta measurement in there. So you just do the best you can, and when I do it, I get theta is about 53 degrees maybe. That's an estimate. Theta is about 53 degrees. But, and this might have occurred to you when I did that first initial blurry blue line there, is that I was going up the y-axis, and remember we're just talking about the top half of the circle today. Well, I have a line going across to here, but I could also go across to this side as well. Now we couldn't do that on the previous example with cos, because cos is an x value, and the x value only gave us one answer. But for sine here, I can get another answer. So if I go across on the other side, I've got another dot. Oh, over here, sorry, theta 1 just popped up, so that's my 53, that's this answer goes there. Theta 1's 53, but I also have a theta 2. I have a second answer here. So my second answer is going to come from the other quadrant, quadrant 2, and that happens when we work with sine. So I have a dot here, and then I'm going to draw a line. I'm going to draw it quickly here so it's not going to be straight, because I don't really like, I have a Wacom tablet and I find it is not that great. Okay, well line didn't draw very well, but there's another answer there. So what I've got here are 2 triangles here. I'll just change colors so you can see a little better. Starting from my initial arm over here, here's my initial arm. Starting from my initial arm over to this one, that's my theta 2. So that red curve here is my second answer. So I get 2 answers here. So I need to measure that angle there with my protractor, the red angle, and that, when I do it, gets to be about 127 degrees. My theta 1, let me just move that up here. My theta 1 was 53 degrees. And my theta 2 is 127 degrees. So I have 2 answers this time. I got 2 answers for one question, which is still a function, right? That's like when you put in a quadratic, if you have a parabola like this, and I give you the answer, I said, when is the y value 10? Well, it could be when x is 2 or when x is -3. That's what all our factoring gives us. So we have one answer, but we could have two possible inputs. So we have theta 1 could be 53, that's this one here, and theta 2 is the red one. We could also have this answer over here. Notice that any equation in the form y equals sine of a number, like the one we just did, will have two solutions. If you use your calculator to find one, you don't actually need to draw the second one like I did. You can just subtract from 180 to find the other, right? Because whatever we got for this blue theta 1 here, 53, that will also be this space over here, this related acute. So this would also be 53. So I don't need to actually measure my second angle. And when I give the test or quiz on this unit, I allow the very basic calculator. So if you needed to put in 180, subtract 53, you could. But all you're doing is subtracting this piece here to get your theta 2. So the answer y for that is because this related acute is a 53. So 53, 180 subtract 53 will give you your second angle. So you don't have to actually draw it and calculate it. You just need to figure out one of them. Okay, part C, next one. So you're getting the hang of this? Now might be a good time to press pause and try this one yourself. Obviously I'm going to show you the whole solution, but maybe give it a shot. I'll get you started. Remember that cos is x. Your x value is -0.8. So you're going to start with putting your x value here, -0.8. You're going to start going across there. So try that and then come back to the question. Okay, so I put in blue here my x value. This is the length of x equals -0.8. That's what I put in blue. Then I go from my -0.8 x value, which is right about there, and I'm going to go up to my circle, put a dot there. Now that's going to be where my terminal arm is. So from the center of the circle, from the vertex, I'm going to draw a terminal arm there up to my dot. Okay, so we're going to pretend that lined up, but it didn't line up. So here's my terminal arm. Now remember what I'm doing in the question is I'm looking for the angle, right? The angle is the unknown here. Theta is my unknown. So I'm trying to find an angle. That means I'm looking for the measurement from the initial arm to my terminal arm. So I'm going to measure this distance right here. So I'm measuring this distance right here. I don't know why that terminal arm keeps disappearing. This is theta right there. That's what I'm trying to find. So when I measure that value there, I'm going to have the value of the angle. Cos theta equals -0.8. Now I'm not going to write it down yet, but what I want you to do is put this into your calculator. -0.8, you want to find inverse cos of -0.8 and look at your answer on your calculator. Is it kind of close to what you got? Hopefully it is. I'm getting my calculator showing about 143 degrees. So maybe you're 140, maybe you're 147, something like that, but you should be kind of in that vicinity. So that is how your calculator is getting that number right. Well, that's where it's coming from. It's coming from those measurements on the circle. Look back to question A. We had an acute angle in quadrant 1, and the cosine was a positive number. Remember our answer for part A? I think we got 55 degrees or 56 degrees. In that case, we were in quadrant 1, right? So we got a positive answer. We were given 0.56, but we were in quadrant 1. So our 0.56 was a positive number. This time we have a negative number. So when our x is positive, we're going to draw a triangle in quadrant 1, so we should expect our angle to be acute. When x is negative, like this one, we're in quadrant 2 because our x values are negative here. If our x values are negative in quadrant 2, a negative number, then we would expect an obtuse angle, which is what we drew in quadrant 2. For question C, our angle ended up in the second quadrant, which is obtuse angle. The value for this was negative. Why? Right? So this is a negative because it's in quadrant 2. So when our x values are negative, just look at your x-axis. Right from grade 9, positive numbers go this way, negative numbers go this way. So if we have a positive x value, we're going to get an acute angle. If we get a negative x value, that means our angle should have been obtuse. Last slide, we're almost at the end. Example 3, determine the sine and cosine and tangent of 98 degrees using your calculator and sketch the angle. So finally, you actually get to use your calculator legitimately. I want you to find sine of 98, cos of 98, and tan of 98, and then write them in the spot in your handout there. Press pause while you do that. So for sine of 98, if you haven't pressed pause, just do it now or back it up later. I'm getting 0.9903. Cos of 98 is now 98 degrees. Think about what quadrant 98 is in, right? 98 would be in the second quadrant, so I should be getting a negative answer here because cos is x, and that's negative in that quadrant. So we just talked about that, 0.1392. And tan of 98 on my calculator, now this one is not exactly a sine or a cos, it's a combination. Remember, tan is 1 over the other, negative 7.1553. So the question says determine the sine and cosine of 98 degrees using your calculator and sketch the angle. So let's sketch the angle right now, 98 degrees. We're first going to put on the initial arm here on the positive x-axis. There's your initial arms going across that way. And then measure 98 degrees with your protractor. And then press pause and then come back and take a look. All right, I've got my initial arm on there. I measured, I have an orange dot about where it's going to fall. And there's my terminal arm. So I'm looking for, you should have measured theta to get that. Mine's a little off, but you measure your 98 degrees to get that. So you can actually label in here also if you want to. This is our theta in here, and it's 98 degrees. 98. Having a hard time with that 8. 98 degrees is this measurement in here. That's 98 degrees right there. At the bottom it says note, note you can find tan 2 ways. You can use your calculator, that's what everybody did here. I hope you used your calculator. Or you can write it out, tan is sine over cos. Remember from before we realized that tan is the same as sine over cos because it's opposite over adjacent, which is y over x. So you can also find it this way. So I could take sine of 98, which is this number here, sine of 98, divide it by cos of 98, so divide it by this number and see what you get. So right now I would like you to take, on your calculator, I want you to take sine of 98, I want you to divide it by cos of 98, that's these two numbers here, and you should get very close to the same answer, but because we're doing some rounding here, it's not going to be exactly the same. So that's another way to get tan, is if you know sine and if you know cos, you can just use your sine and your cos values to get tan. So one more thing here, yeah. Let me just point out before we finish, tan is larger than the sine and cos are always going to be less than 1 on the unit circle because our unit circle the hypotenuse is always going to be 1. No matter where I draw a triangle here, the radius is always 1, right? And the radius is the longest side. So sine and cos are the same as the x and y values. So on a right angle triangle, the legs of the triangle are always shorter than the hypotenuse. You're never going to get a value of 1. But tan can be. And that's because tan is a ratio of y over x. It's not just the y value or just the x value as cos is. It's the ratio of the two of them. So we're always going to get, not always, but usually we're going to get a number bigger than 1. We can get numbers bigger than 1 or negative 1 because tan isn't just an x or just a y. So your homework, all the questions that are on the handout, and it can really, like, this is a really difficult lesson. I'm actually glad to have made this PowerPoint because when I teach it in class, if somebody is away, they are just lost for days because it's so many important pieces of what sine, cos, and tan are. So it can get confusing quickly. So do all the questions I've assigned. They're all asking for something different. Look on your handout for the matching type of example and use it. Watch the video again, write more of your own steps in again. And this is a big lesson, an important lesson, so please make sure you understand it. Do lots of questions for the homework and ask me questions when you have them. Look on D2L for solutions for questions that might already be there. And don't forget the part on D2L that says need help with a question mark. That has links to other places where you can find solutions to homework as well. Good luck.